The objective of the study is to examine the relationship between economic growth and explanatory variables, including government expenditure, life expectancy, financial development, and trade openness. First and foremost, we try to seek variables which affect the economic growth from the relevant papers. We found that the article about the impact of government expenditure on economic growth in Jordan illustrates there is a positive impact of total government expenditure on economic growth, which supported the Keynesian model. Next, we study on financial development and economic growth in Kenya, and it is showing that the financial development has a significant positive effect on economic growth.
In the literature review, labor force participation for a country is that labor force participation is a pervasive feature in many developing countries. Increase in the number of labor force out of the population will cause the enhancement in productivity and increase the economic growth. The finding in the article shows that the labor force participation negatively related with the economic growth according to the high rate of unemployment and inequality in employment opportunities. Then the paper analysed the impact of trade openness on the economic growth in multivariate framework, including the capital stock, labor, and trade openness as regressor. The finding shows that the trade openness positively related on the economic growth in the short and the long run, according to the theory of comparative advantages. The country with more trade openness are likely to outperform than country with less trade openness.
Additionally, this study used cross-sectional datasets from 50 countries in 2018 from World Bank website. And after we studied the 4 articles, we found its relationship between economic growth and 4 variables. Therefore, this is our multiple regression model. From our data sets of 50 countries in 2018, we calculate and get the mean value, median value, standard deviation value, minimum value, maximum value of each variable.
Here is multiple regression model. GDP refers to annual growth of GDP. GOV refers to general final consumption expenditure of government. LFPR refers to labor force participation out of total population age 15 above. Money refers to broad money, and radio refers to ratio of total export and import to gross domestic product.
After constructing the multiple regression equation, we then run the equation in EView to see the result. Shown is the coefficient or the estimated value of the beta hat of the equation. C is the beta hat naught, government is the beta hat 1, LFPR is the beta hat 2, money is the beta hat 3, and tradio is the beta hat 4. GDP being the dependent variable. Diagnostic tests are used to make sure that our regression equation consider all the classical assumptions to make sure that the estimation of regression will be good using the OLS estimator, because there are consequences when the classical assumptions are being violated, such as OLS estimator being biased, or OLS estimator has a bigger variance, or hypothesis testing will be affected, and more. So for this paper, we focus on specification error, multicollinearity, serial correlation, and heteroscedasticity to see if we have this problem. So first, we move to specification error. So this happened when we violate the first classical assumption, which is regression equation should be correctly specified. So specification error happen when we exclude important variable and include irrelevant variable, or not use the correct functional form. To test if we have this problem, we use the Ramsey reset test, and we add 2 variables as proxies to see if they can help to explain the dependent variable. If they can explain the dependent variable, then we have that problem. So this is the EView. And also we use the F-test, and from the results, the test statistic is seen to be less than the critical value, meaning that we accept the null hypothesis, meaning that we do not have the problem of specification error. There are 2 types of multicollinearity, but we focus on the imperfect one, which do not violate the 6 classical assumption, but is still a problem of multicollinearity. So we do the auxiliary regression to check if we have this problem, where we regress each of the explanatory variable on other explanatory variable, because we have 4, so we do 4 auxiliary regressions. So this is our result from all the EViews. We found that the R squared from each of the EViews is less than 0.8, which means that we do not have a problem of multicollinearity. Since
error terms are not observable, we use proxy for them, which are the residuals. And we use two tests to test if we have this problem, which are the Durbin-Watson-Gee test and also Brooch-Godfrey LM test. So for Durbin-Watson-Gee test, we do for first order serial correlation with this equation, and we run the EViews, and then we do the hypothesis testing, the D test, and we get critical value from the DW statistical table, and we find that the test statistic value is in the except H0 region on the number line, so we do not have first order serial correlation. Then we do the Brooch-Godfrey LM test for second order serial correlation, where we run regression of the residual on the past value of residual and the explanatory variable of the model with this equation, as well as we run the EViews, and then we get we do the F test. So we find that the test statistic is less than the critical value, meaning that we accept H0, so we do not have problem of serial correlation up to second order. So from both of these tests, we do not have problem of serial correlation.
We run the equation to check for any heteroscedasticity problem, and in this case, we use the White test. We want to see whether the explanatory variables and the squared have an effect on the residuals squared. If yes, then the errors are heteroscedastic, and if not, the errors are homoscedastic. We use 0.05 level of significance, and our critical value is 15.5. We obtain a test statistic of 1.69, and our p-value is 0.79. The degree of freedom is 8 because there are 8 explanatory variables in the equation. Since the test statistic is smaller than the critical value, it means that we do not reject H0. Our errors are homoscedastic, and we do not need to do any remedial measures to the regression equation. Now that we have the correct regression equation, we will do the test for individual significance. We will be using the same level of significance, which is 0.05 for all the 4 variables. First is for the government. So as seen, our test statistic is smaller than our critical value, and this means that the government expenditure has a significant effect on economic growth. Next is for LFPR, labor force participation. So as seen, this time around, our test statistic is bigger than our critical value, and this means that the labor force participation has no significant impact on economic growth. Next is money. Money is an indicator of broad money. So as seen, our test statistic is smaller than our critical value, but this time around, we will reject H0 because we expected our B3 to be This time around, we expected our B hat 3 to be lesser than 0, but our test statistic is more than 0. Therefore, we can conclude that the broad money has no significant impact on economic growth. Tradio. Tradio is the ratio of total exports and imports. So as seen, our test statistic is bigger than our critical value, but we reject H0 because we expect our B hat 4 to be more than 0. So we can conclude that the tradio has no significant impact on economic growth. To test for overall significance, we will use the F-test on all the explanatory variables to see whether it has an impact on the dependent variable. So we want to see whether all of our explanatory variables are equal to 0, and if it is true, it means that our regression equation have an overall significance. So as you can see, our F value is 2.59 and our critical value is 2.58. Therefore, we can conclude that our regression equation has an overall significance.